The first time I built an authentication system, I used sessions. It worked until I had to connect to a React frontend. Then came the mobile app. Then a third-party client needed API access. Suddenly, managing sessions didn't scale well, and things got messy fast. That's when I discovered JWT, and it completely changed how I think about authentication. Here's the problem with traditional session-based authentication. The server has to remember every user's session. It stores who logged in, when, and what their role is. This is fine until your app grows. If you are building REST APIs for your modern frontend, React, Angular, mobile apps, or external integrations, session storage becomes bottleneck. You need a stateless, secure way to handle user identity without overloading your servers or complicating your architecture. This is where JWT or JSON Web Tokens comes in. Instead of the server remembering the user, we give the user a signed token after login. That token carries all the necessary info like their identity and role. Every request includes the token, and the backend just verifies the signature. That's it. No need to store anything. It's fast, secure, and stateless. Another thing that we also need to consider: access tokens are short-lived. What if they expire while the user is still active? That's why we will also introduce refresh token, longer-lived tokens that allow us to issue new access tokens without making the user log in again. In this tutorial, I will show you how to build a complete JWT-based authentication system using Spring Security, from login to token renewal. Here, what we will build together in this tutorial. We will start by creating a secure REST endpoint where user can log in with a username and password. Once they are authenticated, the server will issue an access token. This token will be used to prove their identity on future requests. Along with that, we will generate a refresh token which will be sent securely and stored so the user does not need to log in again when the access token expires. Then I will show you how to use that refresh token to renew access tokens without re-entering credentials. We will also create a custom JWT filter that checks each request for a valid token before letting it through. And finally, we will secure specific routes so only authenticated user can access them, keeping your API safe from unauthorized access. And we will set expiration for token and handle logout safely. By the end, you will have complete stateless and secure authentication setup ready for any front-end client. This setup is not just a theory, it's used in real-world apps every day. Whether you are working on an e-commerce site, a healthcare portal, or a task management API, JWT lets you scale your backend without the headache of session storage. After this tutorial, your Spring Boot backend will be ready to authenticate any client, browser, mobile, or third party with clean, stateless JWT authentication. You will finally have control over who accesses your API and how. So, let's get started.
I'm going to create the project from scratch. Here is my IDE opened. Click on this new project. From this window, make sure Spring Boot is selected. By the way, I'm using IntelliJ IDE Ultimate Edition. Creating a Spring Boot project directly from the IDE is only available in the Ultimate Edition. If you are using the Spring Tool suite for Eclipse, there is an option for creating a new Spring Starter project. You can try that. There is also another online tool at start.spring.io where you can create Spring Boot project. I prefer the IntelliJ IDEA for all of my Java work. This is great for Spring Boot projects because it comes with built-in tools that make development much easier and faster. It not only autocomplete the method names but also suggests full code snippets that you can insert with a single press of the tab key. You will see me using this feature throughout this tutorial. It saves tons of time and reduces the hassle of remembering syntax or writing repetitive code. I highly recommend you use this IDE. Here's some good news. Thanks to JetBrains, the company behind powerful IDEs, plugin, and developer tools, is offering my viewers IntelliJ IDEA Ultimate completely free for 3 months. Just use the link and promo code provided in the description below. This is not a sponsored video. They are simply offering this to my viewers so you can explore the tool without any cost and focus on learning. Now, let's set up our project. First, I will give our project name JWT Security. I am saving this in my project directory. I will check this box to create a Git repository. It's a good practice to track your code. For this project, we are using Java as our language and Maven as our build tool. For the group name, I am using a reversed domain format. This is standard practice in Java. In our case, it is com.learnwithiftekhar. The artifact name is auto-generated based on my project name. You can change yours if needed. Next, I need to select my JDK version. I have JDK 21 installed on my machine. For the Java version, I am choosing Java 21. Spring Boot 3 requires Java 17 or higher. The package type will be jar. Now we need to click on Next. This Next button is below. You can't see this because it's outside the recording area. Now we need to choose the Spring Boot version. You can see all available version in this drop-down. As of this recording, the latest stable Spring Boot version is 3.4.3. So I am selecting that. Next, we need to add our dependencies. I will type each one in the search box. First, let's add Spring Web. Then we need Spring Security. We also need Spring Data JPA for our database operations. I am going to use PostgreSQL as my database, so I will add the PostgreSQL driver. Finally, we need a validation dependency to validate our inputs. Now, click the Create button. Again, you can't see this button because it's outside the recording area. Here, our project is created. On the left sidebar, you can see the files and folders of our Spring Boot project. Let's open one of the most important files of the project, pom.xml. POM stands for Project Object Model. This file contains essential information about our project, including metadata, the Java version we are using, and all the dependencies our application needs. These are the dependencies that we have added while creating the project. Spring Data JPA, which provides easy database interaction. Spring Security for authentication and authorization. Validation for data validation. Spring Web for building web applications. PostgreSQL driver for database connectivity, and several other dependencies to run our application. For implementing JWT authentication, we need a few additional dependencies. Let's add those now. To add third-party dependencies, we'll use Maven repository, which is one of the primary sites for finding and including Java libraries. In our browser, search for Maven repository. This is one of the sites from where we can search and include third-party Maven dependencies. Go to this site. Here in the search bar, let's type JWT-API. We are looking for the library from io.jsonwebtoken. There it is. Let's select this one. We'll use the latest stable version, which is 0.12.6 at the time of this recording. I prefer to use the most recent version. Always check for the most recent version when you are implementing these in your own projects. In this section, you can see the Maven dependency declaration inside this text box. Make sure the Maven tab is selected. Then copy the dependency block. Now let's go back to our IDE. In the pom.xml file, let's paste this. Next, we need the implementation. Let's return to Maven repository and search for JWT-IMPL. Select the same version 0.12.6 to ensure compatibility. Copy the dependency declaration, then paste it into our pom.xml file. We also need a JSON processor for JWT. Let's search for JWT-Jackson. Again, we'll select the version 0.12.6. Copy the dependency and paste it into our pom.xml file. Finally, let's add Lombok, which is an excellent tool for reducing boilerplate code in our Java classes. Search for Lombok in Maven repository. Let's use the latest version. Copy that dependency and paste it into our pom.xml file. That's all the dependencies we need for now. It's time to synchronize our Maven project with these newly added dependencies. Click on the Reload All Maven Projects icon here to synchronize Maven changes. This process will download all the necessary jar files and update our project's class path. Perfect. Our project is now updated with all the required dependencies for implementing JWT authentication in our Spring Boot application. Now let's look at our project files and folders. Closing this tab. Here we have the SRC directory. This holds all the actual code of our project. Let's expand this. Inside SRC, we have two folders, main and test. In the test folder, we write our automated test. In the main folder, we write the actual code. It has two subdirectories, Java for our Java files and resources folder for non-Java files like configuration files, static assets like HTML, CSS, images, JavaScript, and so on. Inside this resources folder, we have a file called application.properties. Every application needs some configurations like in which port to run on, database details, and even the custom settings. In Spring Boot, we put these settings in the application.properties file. Here, we add configurations as key value pairs. Here is a key spring.application.name and its value is JWT-security. In this file, we can set the server port, database credentials, and other settings. I'll show you this soon. Now, here in the Java folder, here we have a package. We have a package based on the group and artifact name we specified when creating the project. This package has one file so far, JWT Security Application. This is our app starting point. Here we have this Java class with our familiar main method. This main method calls Spring application.run. That's the basic structure of our project. Let's run our project by clicking this play icon at the top. Our application is building. Let me expand the console a bit. Our application failed to start. Let's see why. It says failed to configure a data source. URL attribute is not specified. What does it mean? Let's open our pom.xml file. Here, look at this dependency, Spring Boot Starter Data JPA. This helps with database operations. When starting up, Spring Data JPA looks for database settings. Since we have not set up a database yet, it's showing an error. I'll set up the database later. For now, let's comment out this dependency so we can start the app. We need to synchronize the Maven dependencies too. Now, start the application. Great. This time, our application started successfully. You can see Tomcat started on port 8080. If you scroll up in the console, you will see Spring Boot created a password for us. Let me copy this password. Now, I will open the browser and go to the localhost 8080. So, we have this default login page. Here, provide the username. The default username is user and paste the copied password. Sign in. So, we have successfully signed in, but we are getting a white label error with status code 404. That is because we have not defined any endpoint to process the request. Let's do it now. In the next part, we'll create the necessary model classes and start implementing our JWT Authentication service. I am going to create a REST API for our application. Later, I will show you how to secure those APIs with JWT tokens using Spring Security. Suppose in our application, we have a module named product. We are going to create REST API for this module. This API will contain product read, write, update, and delete operations, essentially implementing the full CRUD functionality. This approach will give us a complete picture of how to build and then secure RESTful services in a Spring Boot application. In this part of our tutorial, we'll configure our database connection and start building the REST API that we will later use with JWT. First, let's bring back our Spring Data JPA dependency. I'm opening the pom.xml file and you can see I have commented out these Spring Data JPA dependencies here. Let's uncomment it and then synchronize our Maven project. Perfect. Synchronization complete. Now we need to configure our application to connect with the database. Opening application.properties. As I mentioned earlier, this file contains the configurations for our project. We can set database settings here using key value pairs. Let's start with PostgreSQL configuration. First, we need a database URL. The key for this is spring.datasource.url. For PostgreSQL, the URL format is JWT :PostgreSQL : // followed by the domain. My PostgreSQL is running on localhost using the default port 5432. Then, after a // specify the database name JWT_security. I have already created this database. Let's take a look at it. IntelliJ IDEA Ultimate comes with this handy database tool that lets us work with our database right from the IDE. It's one of those great features that makes development so much smoother. To access the database, click on this database icon, then click plus icon to add a new database connection. Let's select data source and search for PostgreSQL. Now, I need to provide the connection details. Our database is running on localhost, port is 5432. Enter the username and password. Here, specify the name of the database, that is JWT_security. Let's click test connection to make sure everything's set up correctly. It failed. Looks like I provided the wrong username and password. Let's check. Here, I have provided the wrong username. My database username is not root, it's Postgres. Let's update it and provide the password. Now, test the connection again. Great. The connection test is successful. Let's click OK to save it. Now, our database appears in the database tool. If I expand it, you can see we don't have any tables or data yet. We'll create those soon. Back in our application.properties file, let's add the remaining database configuration. We need the username, Spring, data source, username. This is Postgres. The password, Spring, data source.password, provide our database password. And the driver class name. This is spring.datasource.driver class name. For PostgreSQL, the database driver is org.postgresql.driver. Now, let's add some JPA and Hibernate properties. First one is spring.jpa.database. This is equals PostgreSQL. This property is to specify the database which we are using. Then, spring.jpa.showSQL. Set it to true so that we can see the SQL queries in the console. Next, we need to set the dialect with spring.jpa.database platform. It is org.hibernate.dialect.postgresql dialect. And finally, we need to provide DTO Auth property. This is one of the important properties that controls how Hibernate manages the schema. Here, we give the property key spring.jpa.hibernate.dtl-auto. We have a couple of options here: create drop, create, none, update, and validate. Now, let me explain those options provided by DTO Auth. First one is create drop, which creates the database when the app starts and drops them when it stops, giving you a clean slate every time. Then there's create, which drops and recreates the table on startup, useful for testing but you lose all of your data each time. None simply disables automatic schema generation. Update, which is what we'll use in this project. It creates or updates table and columns based on the entity classes without deleting existing data. This is perfect for development when we are making changes to our code. Finally, validation just checks if the database matches our entities without making any changes. If it does not match, the app won't start. I am choosing update for our project since we are in development mode. This way, Hibernate will automatically create tables and columns based on our Java classes without whipping our data each time we make changes. It's super convenient for development. Now, let's add one last property. spring.jpa.properties.hibernate format_SQL. Set it to true. This makes SQL output in the console more readable by formatting it nicely. Now let's start our application to test our configuration. Here this dialog showing that our application is already running and we need to stop and rerun. Mark this checkbox so that it does not show up again and restart the application. Let's check the console. Great, our application started without any errors, which means we have configured our database connection correctly. Now it's time to create our REST API. I will set up the necessary Java classes for our product API. Let's organize our code by creating several packages inside our base package. Create a new package and name it model. This package is for our entity classes. Next, repository package for our data access objects. Then another package, service, for our business logic. And finally, a controller package for our API endpoints. Now, let's start by creating our project model. In the model package, create a new Java class called product. Here is this dialog asking if I want to add this file to Git. I will check don't ask again and click add so it does not keep bothering us. This product class will be our entity. That means it will be mapped with the database table. We need to decorate it with entity annotation. Also need to specify the database table. Use the table annotation. The table name is product. Our product will have a few fields. First an ID field, private, long ID. Add ID annotation to mark it as the primary key. I also want to specify how this ID gets generated. So I will add generated value annotation with the strategy of sequence. Next, let's add name field. Private string name. Give it a column annotation. Set nullable to false. Then a price field. Private big decimal price. This field is also required, so I will mark it as nullable to false. Now, normally we need to write constructors, getters and setters for all of those fields. But since we added Lombok to our project, we can save a ton of typing. Add data annotation. This gives us two strings equals, hash code, getters, setters and constructors in one go. I also add noargs constructor for a default constructor. Let me move this annotation below so it looks cleaner. We also need to create a constructor with just the name and price fields since the ID will be generated automatically. Here I am using shortcut to generate. On Mac it is Command plus N. Choose constructor. Select all the fields except this ID and click OK. Perfect. Our product entity is now ready. Next, let's create a repository for our product. In the repository package, create a new Java class. Make sure this interface is selected. Name it product repository. This interface will extend JPA repository with product as the entity type and long as the ID type. We also need to import our product class and that's it. Spring Data JPA will automatically implement all the basic CRUD operations for us. Now, in the service package, let's create a new Java class, product service. Add service annotation to mark it as a Spring service. In this service class, we need to inject our product repository, private, final, product repository. To inject this dependency, we could write a constructor, but since we are using Lombok, I will just add the all args constructor annotation, which will generate the constructor for us automatically. In this service class, we will define the methods for our CRUD operations, getting our products, getting a products by ID, saving or updating a product, deleting product. Let's implement those methods one by one. First, the method to get all products, public, list. Make sure to import the list from JWTL's package, product, get all products. This method will return product repository dot find all. Next, let's add a method to get product by ID. Optional. This returns an optional from JWTL because the product might not exist. Product, get product by ID. It accepts ID. The implementation is simply product repository dot find by ID. Give it ID. Now, for saving or updating a product, my IDE is suggesting the code completion. I'll just press the tab. This method accepts product object and returns product repository.save. Finally, let's add a method to delete a product. Public void delete by id. Inside this method, we'll call product repository.delete by id. Give it the ID of the product. That's all for our service class. Now, we are ready to create a controller for our product API and define the necessary endpoints. In the controller package, let's create a new Java class called product controller. We'll add the REST controller annotation to make this a REST resource and provide a request mapping to API/products. In this controller, we need to use our product service. I will declare it as a private final field product service. We need to use a constructor to inject this dependency. I will use Lombok's required args constructor annotation. It automatically generates a constructor for all required fields. Our first endpoint will be for getting all products. I will add a get mapping annotation and create a method that returns a response entity with all of our products. Public response entity get all products. Inside the method, we will return response entity.ok with our product list from the service. Let's start the application and check if we can retrieve data from the database. I will use Postman to test our API endpoints. Click this plus icon to open a new request tab. Since we are testing our get endpoints, I will select get from the drop down. Then I will enter the URL localhost 8080 API/products. Let's send a request. We are getting a 401 unauthorized error. That's because Spring Security is enabled by default and it's protecting all our endpoints. From the console, here is the generated password. Copy this one. Back in the Postman, navigate to the Authorization tab. Choose Auth tab as basic auth. Enter the username user and paste the generated password. Now, let's send a request again. Great. We are getting a response with an empty array, which makes sense since we don't have any products in our database yet. Let's add some products to the database to test our API properly. Opening the database tool, refresh our schema by clicking this refresh icon, and here we can see the products table that was automatically created. Let me click on this edit data so we can add products directly. I will create a product named awesome product with a price 20. Then let's create another one, second awesome product with a price of 10. Then try to commit these changes. I'm getting an error about null values in the ID column. Okay, so we need to give our product ID. Let me fix that. Setting the first product's ID to 1 and the second to 2. Now I can commit the data successfully. Let's go back to the Postman and send our request again. Perfect. Now we are getting our products as an array in the response. Let's finish implementing the rest of our API endpoints in the controller. First, we'll add a method to get product by ID. I will add a get mapping with a path variable for the ID and create a method that takes this ID as a parameter. Hit the tab to complete the auto-suggested code. The method returns response entity.ok with the product from our service. It's showing an error. Let me check the service class. I need to make this method public. Next, let's add post endpoint for creating new products, adding post mapping, and also pre-authorize to check if the user has the necessary permissions. We only want users with the admin role to be able to create products. Creating the method accepting a product object. I'll also add the valid annotation to validate the input before processing. Let's also define validation rules for our product class. I will make both the name and price as not null. Next, we'll create a method for updating products using port. My ID is suggesting the code for this. I will hit tab to accept it. This update operation will also be restricted to admin users only. Finally, we'll add a delete endpoint. Again, my ID is suggesting the code. I will accept it. With that, we have implemented all our CRUD operations in the controller. Let's test all our endpoints in Postman. I'll restart our application to check the changes. Send a GET request to API/products. I'm getting a 401 error again. I need to update the password. Let me copy the new password from the console and update it in Postman. Now the request works fine. Let's try to getting an individual product. I'll create a new request tab, paste our base URL and add /1 to get the product with ID 1. I'll set up the authentication as before. Send the request. We're getting the product with ID 1. Great. Now let's test the post endpoint to create a new product. Select post, set the authorization and switch to the body tab. Choose row. I'll choose row JSON format and provide product details. Name is iPhone and price $600. When I send the request, I forgot to provide the URL. Let's give it. I do not need the ID of the product here. Now send the request. I am getting a 401 unauthorized error. This is expected since Spring Security is checking for CSRF tokens by default. For simplicity, we'll disable CSRF protection later. Though in a real-time application, you would want to handle CSRF properly. I have another video on my channel that explains how to handle CSRF tokens correctly. Please check that video if you want to know more about this. Back to the IDE. Close all the tabs. Now, let's configure Spring Security to implement proper authentication with user roles. First, in our model package, creating new Java class, user. I also need another Java class, role. Make sure it is Enum. For this application, I will define two roles, user and admin. Back in the user class, mark it with entity. For the table name, it is user. Actually, this user is a reserved keyword in PostgreSQL, so we cannot use this one. I am going to give the table name as application_user. Our user entity needs to have primary key. Give annotation ID. The ID will be generated automatically. Generated value, strategies, sequence. Private, long, ID. Then our user will have full name. Give it a column annotation. Name, full name. Nullable to false. Add a validation rule. Not blank from Jakarta validation constraints. Also, give size annotation to provide size limit. The minimum size is 3 and max is 50. If this size validation fails, then it will provide a message. Now, give a message for not blank. Name is required. Then, we need username. Column annotation, make it nullable to false and set it unique. Private string username. Add validation not blank with message username is required. Give it size minimum 3 and max 10 and give it a message. We need password, private string password. It is also not nullable. Set it to not blank with the message password is required. Size minimum is 3. There is no maximum limit. Message password must be at least 3 characters. Our user will have role, private role. As we have made our role class as enum, so here we need to add annotation enumerated and tell the enum type is string. For generating getters, setters and constructor, I will use loombook annotations. Data, no args constructor, all args constructor and builder. Besides, I will need another constructor with all of the fields except the ID. Generate, constructor, select all the fields except ID. OK. With that, our user entity is ready. Now, I am going to create the user repository. Inside the repository package, create a new interface, user repository. It extends JPA repository with user as the entity type and long as the ID type. We need to import this user. Here, we can see that we have a couple of user classes that we can import from. choose this one from the model of our project. That is what we have created. We need to define method for our custom query in this repository. Optional, user, find by username. It accepts username as parameter. We need another method, return type boolean, exist by username. That's it. Here, we do not need to write the query. Spring Data JPA will automatically generate the implementation based on the method names. If you want to know more about this repository, check my other video tutorial on the Spring Data JPA crash course. Now, in the service package, I will create our service class for the user. Create new Java class, name it custom user details service. This service will implement the user details service interface required by Spring Security. We need to implement the load user by username method, which Spring Security will use during authentication. Mark with service annotation. Let's add the required args constructor annotation here. We need to inject user repository, private user repository. In the load user by username method, let's define a user variable. Make sure to import this user from our model package. Now we'll use user repository dot find by username. If cannot find the user, we'll throw an username not found exception with message user not found. And finally, return user. This return type is actually from Spring Framework .security.core.userdetails. In the constructor, we need to provide three things: username, password, and authorities. We have already retrieved the user from the database and stored it in our user variable. So, for the username, we'll use user.getUsername. Then the password. And finally, we need to provide the authorities. For the authorities, I will create a new method called getAuthority that takes our user as a parameter. Let's create this getAuthority method now. This method returns a collection of granted authority object. Basically, an authority represents a user's permission or role in our system. We need to return an object that implements the granted authority interface. I will create a variable of type granted authority, and I will instantiate simple granted authority, which is an implementation of granted authority. I will pass our role name as the constructor parameter. For our user, we have only defined a single authority, but we need to return a collection of authorities. So we can use list.auth and provide our authority object. We need to make this repository field final. Great. Our custom user details service is now complete. Now, in the controller package, let's create a new Java class called Auth controller. We'll add the REST controller annotation and set the request mapping to API/auth. This controller will handle all our authentication related logic. First, let's implement the register functionality. We'll use post mapping for register. This public method will return a response entity. Name register user. For the method parameter, we'll add valid annotation to validate our request. Then request body. It will accept a register request object. We have not defined this class yet. Let's create a class for our registration request. In the base package, let's create a new package called DTO. Inside this package, we'll create a new class called register request. I will add several annotations: data, builder, no args constructor, and all args constructor. Now we need to define the fields needed for registering a new user. Let me open the user class. Here, let's select all the fields except the ID, copy, in the register request class, paste it. Now, in the user class, this is actually our entity. Here, we do not need these validation rules. Let's remove them. And also, scrolling up, also remove these unused imports. Now, close this user class. In the register request, this is our DTO. Here, we do not need these column annotations. Let's remove them. Removing column annotation from username and password, and also for role, we do not need this enumerated annotation. Now, let's remove those unused imports. Back to the auth controller. Now, let's import this register request class in our auth controller. Here, we'll save the new user to the database and return a success response. For the authentication business logic, I will create a separate service. Inside the service package, let's create a new class called Auth Service. I will add the service annotation and all args constructor. We need to inject two dependencies, private final user repository. Another one is password encoder for encoding passwords. Looks like we have an error. It cannot find any bean for password encoder. Let's define that bean. Let's create a new package called config. Inside this package, create a new Java class called security config. Add the configuration annotation, enable web security, and also enable method security. In this class, let's define a bean for our password encoder. Public password encoder, and that returns new bcrypt password encoder. Now back to the auth service. Let's define a new public method called register user that accepts a register request. First, we'll check if a user with the same username already exists. We will use user repository dot exist by username and pass the username. If the user exists, we'll throw an exception with the message user already in use. If the user doesn't exist, we'll save the user. Let's create a new user instance. I'll use the builder pattern for this. User.builder.username and pass register request dot get username. Then for the password, we need to encode the password with password encoder dot encode and pass register request dot get password. Finally, we will set the role and call build. Now save the user by calling user repository dot save and pass our user object. We should add the transactional annotation at this method since we are doing a database operation. This helps prevent exceptions. Now let's go back to our auth controller. We need to inject our auth service, private final auth service. Inside our register method, we'll call auth service dot register user and pass the register request. Then I'll return response entity dot OK with a message saying user registered successfully. Now we need to configure Spring Security to use JWT for authentication. We will customize Spring Security to use our custom user details service, define an authentication manager, and register a custom filter that will check and validate tokens. Let's open the security config class again. I will add a private field for UserDetailsService and annotate the class with required args constructor. When our application starts, Spring Security will look for any class that implements the UserDetailsService interface. Since we created our custom class that implements this interface, Spring will automatically find it and inject it here. This is a really cool feature of Spring's dependency injection. We don't have to manually wire things together. Spring will see that we need a UserDetailsService in this class and provide our custom implementation. Let's define a bean for Authentication Provider. Public Authentication Provider. Name Authentication Provider. In Spring Security, the Authentication Provider is responsible for validating authentication requests like checking if a username and passwords are correct. For our application, we'll use DAO Authentication Provider, which is perfect when we are storing users in a database. DAO stands for Data Access Object. This provider knows how to fetch user details from the database using our user details service. Set our custom user details service so it knows how to find users. And set our password encoder so it knows how to verify passwords. Then return this provider. We also need to define another bean for Authentication Manager. The Authentication Manager is a core interface in Spring Security that processes authentication requests. It acts as a coordinator between different authentication providers. When we receive a login request with a username and password, the Authentication Manager will pass that request to our DAO authentication provider to validate it. This method accepts an authentication configuration parameter and returns authconfig.getAuthenticationManager. This method throws an exception. Let's add that to our method signature. Spring Boot will automatically configure this manager with our custom provider. Now let's define our security filter chain. This is where we configure all the security rules for our API. It takes an HTTP security parameter and returns http.build. In Spring Security, the security filter chain determines which requests are secured and how. Think of it as setting up security checkpoints for different paths in your application. Before returning, we need to customize our filter chain with several implementation settings. First, I will disable CSRF protection by using http.csrf. Inside this, I am using lambda expression csrf arrow csrf.disable. I am using a lambda expression here, which is more modern way to configure Spring Security in recent versions. I am disabling this because REST APIs typically don't need CSRF protection when using JWT tokens. Since each request will need a valid JWT token, this protects us from these attacks already. Next, I will configure which endpoints are accessible without authentication using authorize HTTP request. For any request matching the pattern API /auth/ and anything after that will permit all. Our registration and login endpoints will be publicly accessible, which makes sense because users need to be able to register and log in before they have a token. For all other requests, we will set them to authenticated, meaning they will require a valid JWT token. This protects all our products endpoint and any other API endpoints we create. Finally, I will set our authentication provider to the bean we defined earlier. This tells Spring Security to use our custom DAO authentication provider for authenticating users, which connects to our database through the UserDetailsService. All these settings work together to create a secure API that only allows access to authenticated users with a valid token. Let's start the project and see if everything works. In Postman, I'll open a new tab to register a user. The URL is localhost 8080/API/register, and this is a post request. In the body, I'll select row, JSON, and provide the user information. Full name is my name Iftekhar Hussain, username is Iftekhar, and I will add a password and role admin. Now let's send a request. Nothing happens. Let's check the console. We have an exception. Null value in column full name. Okay, let's check out auth service. Here is the issue. I forgot to set the full name. Let's add .fullname register request .get full name. Let's register the project. Now let's register the user. Back in the Postman, let's send our registration request again. Great. Our user has been registered successfully. Now let's try to access the product list. When I send the request, we get a 403 forbidden response. Let's check the console. Spring Security is not generating any password anymore. Let's try logging with our new user. Username, Iftekhar, and our password. Still forbidden. This means we need to create our own authentication logic. Let's plan how we are going to authenticate users. Before we dive into implementing the actual authentication, let's understand the big picture of how Spring Security works. This will help us see where our JWT authentication fits in. Let's start at the beginning of the flow. First, when a user sends a request, the container creates a filter chain. This filter chain contains various filter instances and the servlet that should process HTTP request based on the path of the request URI. Think of filters as security checkpoints that the request has to pass through. One of the filters in this filter chain is the authentication filter. The authentication filter delegates the authentication request to the authentication manager. Based on the response it gets back, it configures the security context. The authentication manager uses one or more authentication providers to process the authentication. It's like a coordinator that knows which provider to use for different types of authentication. The authentication provider is where the actual authentication logic happens. It contains the rules to decide if a user is who they claim to be. Supporting this, the UserDetailsService implements the user management responsibilities, which the authentication provider uses in its authentication logic. This service is responsible for retrieving the data like finding a user by the username. Similarly, the password encoder implements password management, which the authentication provider also uses in its authentication logic. This ensures passwords are securely handled. After successful authentication, the security context keeps the authentication data. You can think of it as a secure storage area for the current user's authentication information. Finally, the security context will hold this data until the action ends. In a typical thread per request application like ours, that means until the app sends a response back to the client. Now, where does JWT fit into all this? Here is our plan. We are going to introduce a custom filter named JWT Authentication Filter. We will instruct Spring Boot to place this filter before the username password authentication filter in the chain. This ensures our JWT validation happens early in the process. This JWT authentication filter will intercept every request and check if it contains a valid JWT token. We will also define a service named JWT Service that knows how to handle everything related to JWTs, like creating tokens, validating tokens, and extracting information from tokens. Our JWT authentication filter will use this JWT service to validate the token in each request. If the validation is successful, it will set up the security context with the user's authentication details and forward the request to the next filter in the filter chain. If the token is invalid or missing, the filter will let the request continue without authentication, and then other security rules we have set up will block access to protected resource. This approach gives us a clean separation of concern. The filter intercepts request and extracts token. The JWT service handles all tokens related operation. The standard Spring security components handle authorization once authentication is established. The beauty of this design is that it integrates perfectly with Spring Security's existing architecture while adding the JWT specific functionality we need. In the next section, we will implement this plan step by step. First, we will create the JWT service to handle token operations. Then, we will create the JWT authentication filter to intercept request. Finally, we will update our security config to use our custom filter. Let's get started with implementing our JWT authentication solution. Now, let's create the components we need for JWT authentication. Inside the service package, let's create a new Java class and name it JWT Service. Also, inside the base package, create new package, filter. Inside this filter package, let's create a new Java class named JWT Authentication Filter. Let's add the component annotation to our filter. This filter extends once per request filter, which ensures that our JWT authentication filter will be executed exactly once for every request. The once per request filter requires us to implement a method. So let's implement doFilterInternal. Move this method parameter to a new line for better readability. Inside this method, we will intercept the request, check if the token is valid, and if it is, we will authenticate the user. Let's navigate to our JWT Service class. As I mentioned earlier, this service will handle everything related to JWTs, creating tokens, validating tokens, and extracting information from tokens. First, we need to define a few variables. We'll need a private string JWT Secret for signing the token. Then we need an expiration time in milliseconds. So let's add private long expiration ms. We'll also create a refresh token, so we need another field for holding the refresh token expiration time. Now let's define those values in our application.properties file. Here we'll add our JWT related configuration. First, we'll define app.jwt.secret. We need a strong secret key that's at least 256 bit long for the HS256 algorithm. I will show you how to generate one using the terminal in a moment. Next, we need app.jwt.expiration for the validity period of the access token. Let's make our token valid for 1 hour. For 1 hour, we have 60 minutes time 60 seconds time 1000 milliseconds, which equals 3,600,000 seconds. Then let's set the expiration for our refresh token, which will be valid for 24 hours. That's app.jwt.refresh-expiration with a value of 86,400,000 milliseconds. Now let's set those values in our JWT service field. We can get the values from our properties using the value annotation. Make sure it's from org, Spring Framework, beans, factory, annotation. Then double quote, inside double quote, $, then curly braces. Here provide a property name. In this case it's app.jwt.secret. Same for JWT expiration. Value, it's app.jwt.expiration. And refresh expiration with value, $, curly braces, app.jwt.refresh-expiration. Let's also define a static variable token underscore prefix with the value BRR, that is BRR followed by a space. This is because when we receive the token from the authorization header, it will start with this text. Now let's plan what we need to implement in this JWT service class. We will need method to generate the access token, generate the refresh token, validate tokens, check if a token is a valid refresh token. This is useful when generating a new access token from a refresh token. Let's implement this one by one. First, let's create a method to generate access token. This public method returns a string and accepts an authentication object. Inside this method, we'll first retrieve the user from the authentication object. Let's create a user details variable named user principal and get it using authentication.getPrincipal. We need to cast it with user details. Now we need to set up our dates. Let's create a new date variable called now to record when the token is created. Then we'll calculate the expiration time by creating another date with now.getTime plus our JWT expiration value. Finally, I will generate and return the JWT tokens using the JWT builder. I will set the subject to the username with userPrincipal.getUsername. Add the issued at time with our now variable. Set the expiration with our calculated expiry time. Sign the token using our secret key. I'll use a method called getSignInKey to retrieve our JWT secret. Finally, call compact to generate the token string. Let's create this sign-in-key method. It returns a key object. Here, I will create a new byte array key bytes that equals decoders.base64.decode passing our JWT Secret. Then I will create and return a new secret key instance for use with HMake SHA algorithms based on this key byte array. Let's move this method to the bottom of our class for better organization. Now let's implement the method for generating refresh tokens. The code will be similar to our access token method, so I'll copy that method and paste it below. Let's rename it to generate refresh token. Here we need to update the expiration. It will be the current time plus refresh token expiration millisecond. We also need to add a claim to identify this as a refresh token. Let's create a new map object with string keys and object values. Claims equal new hash map. We need to import this map class. Let's set value to the claim. Claims dot put set token type as key and refresh as value. We are getting an error. Let's change the data type of our map to use string for both keys and values. Now in the token builder, I will add our claims. Here you can see this code of generate access token method is similar to this code of generate refresh token method. Only difference is this portion with claims. This is a perfect candidate for refactoring into a separate method. Let's extract this common code to a new method. Right click, refactor, extract method. The code is extracted to a new method. Give this method a name, generate token. This method will accept an authentication object and an expiration time. I will pass the expiration time from our specialized methods. Let's update the variable name in generate token from JWT expiration millisecond to expiration ms to match the parameter name. Move this generate token method at the bottom. Now in our refresh token method, we'll return by calling the generate token method, passing the authentication and refresh expiration ms. For refresh tokens, we have extra claims, so I will pass this along too. We do not need this portion of code. Let's remove it. Let's update our generate token method to accept a map with string key and object values for claims. In the token builder, adding .claims and provide those claims. Here it is showing error. These claims need to be map of type string, not object. Now we need to update our generate access token method to provide an empty hash map parameter to the generate token method. Now let's implement the method for token validation. This is public method, return type boolean, name is valid token and accepts a token and user details. Inside this method, I'll first extract the username from the token. Let's create a separate method for this called extract username from token. It accepts a token and returns a string. In this method, parse the payload from the token and return the subject. I will use JWT.parser. Verify the token with our signing key. Build the parser, parse the signed claims from token, get the payload, and extract the subject. We have an error here. We need to change the return type of get sign-in key to JavaX crypto secret key. Let's update that. We are extracting the subject from the payload for username because when creating the token, we provided the username as the subject. Now, inside our isValidToken method, I'll call extract username from token to get the username. Then, I'll check if this username equals the username from user details. If not, return false. Otherwise, we'll add a try block where we'll parse the token using JWTs.parser. Verify with our sign-in key. build the parser and parse the signed claims. If parsing is successful, we return the true. If there's an exception, we'll catch it. Let's handle different type of JWT exceptions. Signature exception. Here, I'll print a log. We need to add the SL4J annotation to our class for logging. We need to add the SLF4J annotation to our class for logging. For signature exception, log error, invalid JWT signature. Then malformed JWT exception, log.error, invalid JWT token. Catch expired JWT exception, log.error, JWT token is expired. Catch unsupported JWT exception, log.error, JWT token is unsupported. Illegal argument exception, log.error, JWT claim string is empty. I remember one thing. Here I used component earlier. This should actually be service. Let's fix that and remove any unused imports. Back to the validation method. Here return false. Now let's add a method for checking if a token is a refresh token. This public boolean method is called isRefreshToken and accepts a token. Here I will parse the token and store it into claims variable. Claims equals jwts.parser, then verify with get sign-in key, build parse signed claim from the token and get the payload. For refresh token, I have provided token types as refresh. So in return statement, I'll check if refresh equals claims.get, provide the key token type. If it does, this is a refresh token. Now let's go back to our JWT authentication filter. We need to inject our JWT service and UserDetailsService. Private final JWT service, another private final UserDetailsService. Let's do this through constructor injection. Hit tab to autocomplete the code. Inside the doFilter internal method, I will extract the authorization header from the request. Request.getHeader. This is authorization header. I will also need a variable for storing the JWT token and username. Now we need to check if the auth header is null or if it does not start with BRR followed by space. If either is true, the request does not contain a valid token, so we won't authenticate the user. We'll just pass the request to the filter chain and return. Otherwise, we'll extract the JWT from the request using a helper method get JWT from request. Let's create this method. Create a new variable, make it final, string auth header. My IDE is suggesting the code. Hit tab to autocomplete this. Here, what is happening is that it is extracting the authorization header from the request and store it to the auth header variable and return auth header dot substring by 7. This is because the BRR prefix has 7 characters. This is the format of the token. It starts with BRR followed by space. Then we have this token, and if you count, you'll get 1, 2, 3, 4, 5, 6, and including space, it's 7. So we need to start from the 8th character to get just the token. Now that we have the token, we need to extract the username from it using our JWT service. We have defined a method for extracting username from token in JWT service, but it's not showing in this suggestion. Let's check. Here in the method, we need to make it public. Now we can call JWT service dot extract username from token and pass our JWT as parameter. If the user is not null and the user is not already authenticated, we can check this if security context holder dot get context dot get authentication is null. We'll proceed to authenticate the user. Inside our if statement, we'll get the user details using UserDetailsService dot load user by username. Then we'll check if the token is valid with JWT Service dot isValidToken. Provide JWT and user details. If the token is valid, we'll create a new username password authentication token. New variable username password authentication token, name auth token, this equals new instance of username password authentication token. This takes three parameters: the user details, null for the password since we are authenticating with a token, and the user's authorities. Next, we'll set the details of the authentication token with new web authentication details source dot build details. Provide the request. The web authentication details source creates a web authentication details object which contains additional information about the request like the IP address and session ID. This information is not used for authentication decisions, but it is stored with the authentication object and can be useful for auditing, logging, or debugging authentication related issues. Finally, we'll set this authentication in the security context with security context holder dot get context dot set authentication. Provide auth token and pass the request and response to the filter chain. Now let's update our security config to use our JWT filter. First, let's inject our JWT authentication filter as a private final field. In the security filter chain method, let's define our session as stateless since JWT is stateless by nature. We'll use session management session creation policy dot stateless. We'll also need to add our JWT authentication filter before the username password authentication filter. We do this with add filter before JWT authentication filter and provide username password authentication filter dot class. Now let's work on implementing the login functionality. Opening the auth controller. Here add a post mapping. It's for login. Public response entity. Method name login. In the method parameter, I am adding valid annotation for input validation. Then another annotation, request body. This method will accept login request as request body. This login request is not defined yet. Let's create this class. Here, for the destination package, it will be inside DTO package. Click OK. For login, we need username and password. Let's define these fields in this class. Private string username and private string password. Add validation rule for username, not blank with message username is required. For the password, not blank with message password is required. At the top of the class, we need annotation, data, no args constructor and all args construct. Back to the auth controller. Here, we will authenticate the user. If authentication successful, we will return the access token and refresh token. In our auth service, I will define the logic for authenticating the user and generating the token pair after authentication is successful. Open the auth service class. Create a new public method. Return type is token pair. Login. It accepts login request. We need to create this token pair class. Opening the sidebar. Inside DTO package, new Java class, token pair. This class will have two properties, private string access token and private string refresh token. Now let's provide annotation for generating getter and setter methods. Give it data annotation. Back to the auth service class. Here import token pair class. Now let's authenticate the user. authentication. We need authentication manager to authenticate the user. So we need to inject it. Define a new private field. Final authentication manager. Now in login method, authentication equals authentication manager dot authenticate. Here we need to provide a new instance of username password authentication token. In the constructor, we need to provide username login request dot get username and login request dot get password. Now set the authentication in the security context. Security context holder dot get context dot set authentication. Provide the authentication. Now generate the token pair. Token pair equals JWT Service dot generate token pair. Provide the authentication. We do not have this method in our JWT service. Let's create this method. So our method is created. Now let's move this method to the top. Here first generate the access token. String access token equals generate access token, pass the authentication. Then the refresh token, generate refresh token. Return new instance of token pair. Provide access token and refresh token in the constructor. It's showing error. Let's check token pair class. Here we need all args constructor annotation. Now in the auth service, here return this token pair. We actually do not need to define a new variable for this. We can directly return this from here. Remove this variable. Now back to the auth controller. Here let's remove these comments. Here I will generate the token pair with auth service dot login and return the response entity with a token pair. Now let's test if everything works. Start the project. In the Postman, open a new tab. For login, it is a post request. URL is localhost 8080/API/auth/login. Navigate to the body. It's raw and data type is JSON. Provide the login request body, username and password. Send the request. It's showing 403. Let's check the console. Here is an exception. Let's check the reason. The message is the specified key bytes array is 0 bits. Okay. It must have a size greater than or equal to 256 bits. It looks like there is an issue with JWT Secret key. Let's check JWT Service. Here, let's remove this field. We have not used it anywhere. Here, we are setting the JWT Secret. Let's check the value of the secret key in the application.properties. I forgot to provide the secret key here. Let's generate a secret key. Open the terminal. For generating a secret key, I am using the command open SSL, then rand. I want it to be base64 encoded. And for key size, here we need a key that at least 256 bits. 256 bits means 32 bytes. So I am providing 32. Press enter or return if you are using Mac. Our key is generated. Now copy the key, paste it in application.properties file. Start the project. Now let's check this in action. In the Postman, send login request. Our token pair is generated. Let's verify it. Open our browser. Go to jwt.io. Here in this text box, remove this old token and paste ours. So this is our decoded token. This is token subject, issue time. Let's verify the signature from the application.properties file. Copy the secret key and paste it into this input field. So our signature is verified. Now here I want to make a small fix. Here in the header of our token, we only have this signature algorithm, but I want to add type along with this. Let's check what a typical JWT token contains. Refresh this page. See, with the default token that is provided in this page, type JWT is present in the header, but our generated token does not have this. I want to include it in our token. Let's do it. Back to the IDE, open JWT Service. Here we are generating the token. I want to add a header, then add. Here we can provide key value pair for the header property to include. Type is key and value is JWT. JWT with all capital letter and other properties. Now restart the project. In the Postman, send the login request again. Here our new token pair is generated. Let's copy the access token and paste it. Here you can see we have this type property in the header. Now let's check the refresh token. Copy and paste it in the browser. This is our refresh token. In the payload, we have this extra claim, token type refresh. Now let's try to access the API endpoints with these tokens. Copy the access token, navigate to this tab. This was the API request to get all the products. Here, change this auth type to BRR token, paste the access token into the token field, send request. Now here we are getting the response. Let's check the request for getting the single product. Change the auth type, send request. Perfect. We are getting the response. Now let's try to save the product. This was the post request for saving the product. Navigate to the authorization tab, change the auth type, send the request. It's 401. Why? Let's check the console. Here is an exception. It's saying duplicate key value violates unique constraints. ID 1 is already exist. Okay, here is the problem. Let's check our data from the database. This is our product table. Here we have manually added these two products for testing our APIs. But in our product entity, we have defined the ID generation type as sequence and it will be automatically generated. So when we send the request, it generates a new sequence number. For the first request, it is 1. So it is trying to save the product with ID 1. As we have already a saved item in the database with ID 1, it's throwing this duplicate key error. Let's remove this data from the table, delete this product, also the second product, and commit the changes. Our data is deleted. Now in the Postman, navigate to this first step, send request. We have this empty array in response since we have deleted the products. Now let's add a new product. Send the create request. The response status is OK, and in the response body, we have the newly added data. Let's try to get all products. Navigate to the first step, send request. Here we have this newly added data. Let's try to update this product. Open a new tab. For updating, it will be put request. URL is localhost 8080/API/product/ID. It is 2. Navigate to the body. It's raw and JSON data type. Here is the update. Let's say we want to update the price to $550. Send the request. There is an error. It was unsuccessful. Let's check the console. Here, validation failed for argument 1. That is, product name is null. Okay, this is because in our product, we have added validation rules. Its name and price should not be null. Let's update the request body, add a name, and send the request. It seems a new product is added instead of an update. Let's check. Get all the product, send the request. Yes, the new product is added instead of update. Okay, let's fix it. Navigate to the product controller. Here is the method for updating the product. Here we need to set product ID. Product.set ID. Now restart the server. Let's try to update. Send the request. We are getting the response. It seems our product with ID 2 is updated successfully. Let's check by fetching all the products. Yes, our entity is updated. Now let's try to delete this product with ID 3. Open a new tab. It's a delete request. URL is localhost 8080 API products, then ID of the product that we want to delete. Set the authorization header and set the request. We have the response. The product was deleted successfully. Let's verify this. Fetch all the products again. Yes, we have only one product right now. So until now, we have tried this CRUD operation with a user who has admin roles. Remember, we have restricted create, update and delete operations to only the admin users. Let's register a new user with the role user and try to test if we were successfully restricted the access. Which one was our register request? Things become messy. This was our register request. Here, changing the username and change the role. Send the request. The new user is registered successfully. Now log in with this new user. Update the username. Send the request. Here we have this token pair. Now let's check if we can get all the products. Navigate to the first step. Update the token. Send a request. Yes, the data is accessible. Now the next step for getting specific product data. Update the token. Send request. We are able to access this as well. Now let's try to add new product. Update the token and send the request. This time 403 status code. So the user without an admin role cannot add a new product. Let's check if we can update it. Update the token. Send request. Same response. 403 forbidden. And for delete request, it's forbidden as well. So we have successfully implemented JWT Authentication and Authorization. Now it's time to generate an access token from a refresh token. But before, I'll do some refactoring. Open the JWT Service class. Here, this is our generate token pair method. Let's scroll down and see if we can refactor anything. This is the generate token method. Then this one is valid token. Here we are parsing the JWT, verifying with the secret key and parsing the sign claim. Okay, scroll down. Here in the extract username from token method, we are doing the same thing in this portion of the code. Scroll down further. We are doing the same thing again with this isRefresh token method. So this is the perfect candidate for extracting this portion of code into a different method so that we do not have to repeat it. Let's select this portion and extract. I want to extract into a new method. Here the code is extracted into a new method. Let's give it a name. Extract all claims. Here I want to surround this with try catch block. Click on this surround. Try catch. Here it will catch any JWT exception and throw runtime error. My IDE is suggesting a refactor collapse catch block. Here what is happening is that first a variable claims initialized with null value. Then we try to parse the JWT payload and store it to the claims. If there is any exception, it will be thrown as a runtime exception with the exception message. And finally, return claims. Now, let's clean up other methods. In the extract username from token method, define a new variable, claims. This equals extract all claims. Provide the token as the method parameter. Now, if the claim is not null, then return claims.get subject. Otherwise, return null. Scrolling up, let's check other code. Here, we actually do not need this long try catch block anymore. Let's remove it. Here, we are extracting the username from the token. Let's remove this if statement. Now return, check if username is not null and username equals userdetails.getUsername. If both cases are true, only then isValidToken method will return true. And also, I want to rename this method validate token for user, and below create another method public boolean isValidToken. It accepts only token. It will check and return if extracted all claims are not null. Scroll down. Here is the refresh token method. I am adding another if statement. If claims is null, then it will return false. Now navigate to JWT authentication filter. Here it is showing an error. That is because we have updated the method name. It will be validate token for user. Here before extracting the username, I want to do a validation. Let's add a comment so that we can remember what we are doing here. So here if statement, if JWT service is valid token, actually if it's not valid, then pass the request and response to the next filter of the filter chain and return without authenticating. That's all for refactoring. Back to the auth controller. Here I am going to create a new method for generating access token from refresh token. It is post mapping refresh dash token. Public method returns response entity name refresh token. Give it a valid annotation to validate the input and add request body annotation. It will accept refresh token request. Here we need to create this refresh token request class. Open the sidebar. Inside the DTO package, create a new Java class refresh token request. It has only one field, refresh token. Annotate this class with data and all args constructor. Now back to the auth controller. Import this refresh token request class. Inside this method, we need to generate the token pair. We will use auth service dot refresh token. To validate the refresh token, we will use auth service dot refresh token. In this refresh token method, we will validate the refresh token and generate a new access token and return the response entity with the token pair. Now let's create this method inside our auth service class. So our method is created. Here we'll check if it is a valid refresh token. If JWT service dot if refresh token. If it is not valid, then throw an illegal argument exception with the message invalid refresh token. Otherwise, I will extract the user from the token. JWT service dot extract username from token. Provide our token. Let's define a variable for holding our refresh token. Now replace this method parameter with the token variable, and this method accepts token. Now I need to get the user from the database. User details. Here to get the user from database, I will use UserDetailsService. Let's inject it. Private final UserDetailsService. Now back to the implementation. UserDetails equals UserDetailsService dot load user by username. If UserDetails is null, then throw a new exception with the message user not found. Otherwise, create a new variable username password authentication token. Name it authentication. This equals new username password authentication token. Here in the constructor, we need to pass user details, then the credentials, it is null, and the authority of the user. Now we'll generate the access token. JWT service dot generate access token. Pass the authentication and return new token pair with access token and refresh token. I think this token name is causing some confusion. Let's rename it. Name is refresh token. So it is updated. Now For testing this refresh token, I will make the access token expire early and use the refresh token to generate a new access token. Open application.properties file. Here, let's change JWT expiration to 10 seconds. Now, let's start the application and check if it works. Let's log in the user. This was our login request. Send a request. Token is generated. Copy the access token. Navigate to the first tab. Paste the token. Send the request. So, we are getting the result as the token is valid. Now, if we send another request after 10 seconds, we will get this 403. That is because our token is expired. Let's generate a new token from the refresh token, which was our login request. This one. Here, copy this refresh token, open a new tab. For refresh token generation, it is post request, URL is localhost 8080/API/auth/refresh-token. Then navigate to body, row, provide the refresh token request body, refresh token, paste the token, and send request. New token pair is generated. Let's copy this new access token. Navigate to the first tab to get all the products. Paste the token. Send the request. So we are getting the response. If we send a request after 10 seconds, it is 403. The token is expired. So we did the refresh token functionality successfully. Let's revert back the access token expiration time to 1 hour.
Now, we have a solid JWT authentication system with role-based access and refresh tokens. But there's one more thing. What happens when a user logs out or when you need to revoke a token? Right now, our system has no way to remember a token should no longer be valid. And that's the problem. In the real world, you need more control. Maybe an admin wants to force log out a user. Maybe a refresh token gets stolen. That's where Redis comes in. In the next video, I'll show you how to fix this using Redis. You'll learn how to track, backlist, and instantly invalidate tokens, something every secure system should have, but most don't. Click the video on the screen now to start building token management with Redis and take your authentication system into the next level. I'll see you there. Bye bye.